Okay, we're going to try this again. I'm going to try to record steps necessary to complete the lab assignments. I'm going to start with lab 10. This will be my first attempt at doing this. That's why I say my first. I'm going to probably have to have a lead in here. It doesn't look to me like I'll be able to pause, which is kind of a little frustrating. I kind of was hoping I could pause and then move the camera around so that you could see what I'm doing. We'll take a shot at doing this and see what happens. This is a little bit terrifying. I've selected to have it follow my face, and it then zoomed in. So I've got the 60 minutes shot. Let's see if it really does. Oh, well, there you go. This is weird. It is actually following my face. Huh. Can't. Okay, so I've got my selection of resistors ranging from the 100 ohm on this side to the 100 kilo ohm on this side, and here is my 10K potentiometer. I'll be using a proto board similar to the ones you have. I mean, the connection points are all the same, and so hopefully you can wire it up. We're going to take a look at figure 10.2 in your lab diagram. When you look at figure 10.2, you'll see that it has two 10K resistors in a voltage divider with a 10 volt supply, and that will give you roughly 5 volts from A to B. Hopefully you can see that. The two resistors are equal value. So unloaded, we can anticipate that there'll be 5 volt output. As with previous labs, we're going to measure our components first. So we've got two 10K resistors set out. This is a slightly different meter than you've got. The same thing. I've got it set to read resistance. It is not an auto ranging meter, so therefore I set it to 20K because knowing these are 10K, I need to kind of get it in the range. And so measuring the first one, we get 9.88. So 9.88 kilo ohms, and the second resistor is 9.85 kilo ohms, and I'll arbitrarily decide that the first one is R1 and the second one is R2, and now I'll construct my circuit. Okay, so I've constructed the circuit. Can't really see very well, so I'll zoom in a little bit, see if we can actually see them. I've got one resistor here that is actually my R1, another resistor here is my R2. They're connected to the power supply, the ground and the positive lead. And I've got the meter in my hand, and basically I first adjusted the voltage. Oh, I want to be able to see this thing here. There we go. You can kind of see it. Got 10.02, so we're 0.02 of a volt off from positive to negative. And so now we want to look at what the voltage no load of the voltage divider is, and sure enough, it comes out at exactly 5 volts. Now, the next thing that we have to do is to measure the bleeder current, or the current, through that second resistor, this R2 here. Now, if you remember, to read current, we need to change some of the meter setup. So I'm going to turn the video off for a second. We're going to change that setup. Okay, all things being equal, of course, the current fuse in this meter has been blown, so I just ended up having to pull out another meter. What I've done is put in the circuit a gap. So I moved the lead from resistor 2 down 1. That leaves a gap between resistor 1 and resistor 2. And now I'm just going to place my current reading meter across those two, and you can see that I get 0.51. So that would be 0.151 milliamps. So in that setting, or 510 more or less microamps, because I just went down to the 2000 microamp scale on this meter. So we've got 0.51 milliamps, and if I run through my calculation with two 10K resistors and 10 volts, that's 10 over 20K, so it's about 0.5 divided by K, that gives you milli, so 0.5 milliamps is exactly where I want to be. Okay, moving on to step 3 of the procedure. We are asked to connect a 100 kilo ohm load to the circuit. Again, if you look at that schematic diagram, points A and B indicate where the load would be connected. And so in my circuit, I have placed the 100K ohm resistor, brown, black, yellow, in parallel with the second resistor, R2, at my output, which is what we're defining that to be. Again, you can't really see very well. Let me zoom in a little bit, and maybe you can see that I've placed the second resistor here, that one there, in parallel with the previous one. So that's my loaded voltage divider. So when I place the voltage probe across the load resistor, I'm getting now 4.77 volts, down somewhat from the 5 volt. We're going to use that to calculate a percentage of change. I'm going to repeat this process with the other two resistors, or excuse me, the other three resistors, a 47K, a 1K, and then a 100 ohm, and hopefully we will see a decrease in the load voltage. I've put in the other resistors, gradually reducing the amount of load voltage that we're reading until now with the 100 ohm resistor as the load, we get a 0.09 volts. Let me go down one level. And okay, so it gives me 0.098, roughly 1.1 volt. If you were to calculate that as a percentage of the overall, because of the parallel effect of that very small resistor next to 10K, that's probably about right. The voltage readings went with 100K, 4.77, then 4.52, so those ones over 10K are hanging in there. But when we go to 1K, it drops to about 2.41, and now we're down roughly to 1 volt. I thought I'd give you a close-up shot of my circuit. Pretty straightforward stuff. R1 here, R2 here, and then the load resistor attaches in parallel, so they're all connected into that same group of 5 holes across here at number 37, and then the ground lead at 28. So that's our completed circuit.